All right, so today I wanted to kind of share with you how I'm using Claude Code to rewrite some software that I've already developed and used for approximately a year and a half, 2 years, over which time I've improved it and made it better. And I did end up taking all that software down because I stopped using it for about a year and a half, and I didn't want to pay for hosting, so I shut down my whole AWS stack, backed up all the training data, all the data, downloaded it, put it on a couple different disks so I don't lose it, and set it aside because I thought maybe I'll come back to this. And things have changed now, and I've come back to it. I purchased a new drone, and I also am working on potentially doing some more flights and some more trash reporting. So I've been reimagining my entire platform from the ground up because I get to do that as a software engineer. As I'm working on things and I'm using them, I try not to make big changes, and I try to keep the momentum going. But now that I've had some time to reflect and I'm coming back at this with fresh eyes and with Claude Code, I am taking everything I learned and I'm applying it to building an even better version of my previous platform. So I just kind of want to share that with you here today. So what we have here is what I've done in the course of a couple days. This entire site that I'm going to show you was created in a couple days from data I have, from know-how I have, from code examples, things that I knew would help guide this along. I kind of brought them all together and let Claude Code take a look at them, and then got it to build what I really wanted. So the first thing that I did was to rebuild my drone mapping software, which essentially takes a photo with some metadata and it maps it on into the real world. And the reason why that's really important is that you need to understand that when you're doing object detection on one of these photos, where, for instance, if you found a garbage pile like right here, there isn't one there, but let's just say there was a garbage pile here. Let's say we wanted to report something really small over here, but we wanted to report it. We'd want to know where that ends up in the real world, and kind of be able to give it a latitude, longitude, give it an address. And so this mapping code, this mapping application here, takes any photo from a drone, one of the drones where they have the right metadata, and will map it into the real world and pixel by pixel show where that each pixel is located in the real world. Now you see, like, it doesn't line up exactly with the building tops on this satellite image, and that's because it's taken from a different height. And so the angle of these buildings, the fisheye aspect of the lens, all those things create a bit of distortion, but also misalignment with the satellite map. However, all that stuff's been corrected in this photo, and so I had Claude Code write me this algorithm based on stuff I'd done before. I knew exactly what to ask for, and it did everything. It did all the different parts of mapping a photo on the ground that I needed, including correcting the image distortion. It's applying like a rasterized image here on top. It's using OpenGL, so it can actually apply some distortion fixes, but then also it's removing some of the fisheye effect in some ways of like spreading out pixels in certain areas and compacting them in other areas. And in general, it results in a really good, high quality image mapping into the real world. And you can see it lines up pretty well with the streets in the satellite images. So yeah, these drones have like a really high precision GPS, and so you can count on them to have a really accurate location and a really accurate way of mapping to any given pixel on the ground. Okay, so that's that part. I can essentially drop any of these drone images into a directory. It'll scan, process them. I can then calibrate to make sure they look good. So if I have like a new drone, I can go in and calibrate. And then and calibration looks like this. So you have an image and you want to like figure out like how to map it. So you can essentially pull it up here and say if you wanted to like tweak something about it, you can change these and it's going to change how the image maps onto the ground. And so you can kind of get an idea of like how these things affect things and whether something you've done is affecting the image, the way the image maps onto the ground. So as you can see, it's distorting the images in one direction there, and it's updating in real time as I click this to show how the new mapping maps to the ground. So you can see that that's now way off. But if you go back to that again, it comes back and it's more accurate now. All right, so that's that. The other thing that I did now is I've added back in my annotator. So I had an image annotator before, but now I have a new one that I had Claude Code built for me with all my knowledge, which allows me to go in and annotate these images to, for instance, label that there's some garbage here. Now, it says large pile right now. That's actually a misnomer. This should be a label for just garbage. But that being said, this is allowing me to go in and check all these images, add in any annotations that are missing. I can add them to like an approved data set, and then I'll be able to use these data to train better models as we progress through. So I do all that. I can save those changes. I can pan, I can zoom, I can search around looking for garbage piles. And this is not for the reporting side of things. This is for the model training side of things. So my model is a proprietary model that I trained like on data like this. This is the data that my model was trained on. It was never perfect, but it was good enough. And it's a continuous kind of operation, a continuous process of refining these labeled images to figure out the best way to tell the model or to teach the model how to detect garbage piles. Now, what I've discovered is that because garbage piles are made up of all these different bits and pieces, it can actually be really helpful for it to learn to identify any garbage on the ground. But also we're telling it that if it finds contiguous piles of garbage, it should lump those together. And I think that's working pretty well. Models tend to have a texture bias. And so they're really learning the texture of garbage. They're not necessarily learning the shape. And so these are, so this works. Anyway, this is stuff that I've learned over time. But I just go through and I can add all these annotated garbage piles into a data set. But here I just have this nice annotation tool. I can pull up and only show like the ones that I haven't approved yet. But so far I'm starting fresh. I'm taking all my annotations that I already have, and I want to go through one by one. This is this painstaking process of going through one by one and checking every single annotation. The quality of this data set is going to determine how much work I have to do on a day-to-day basis. And so it's really worthwhile to get a high-quality data set. I could pay somebody to do all this stuff, but to tell the truth, this is a little bit therapeutic for me. I enjoy like the process of creating a data set, of learning about what makes a good data set. If I ever turn this into a big company, I won't be doing this on a day-to-day basis. But right now, this company is small enough to where I can do this and it makes sense. Yeah, so save that. And then we can essentially add it to the approved set of data and we hit next. Now, I can do that a bunch, but now I've also added in some cool new features. So now it's kind of annoying to have the list right here. I can't see like where I'm at necessarily progress wise. So I've created a new view that allows me to see things much more comprehensively, and it will give me the ability to click these and then they open up on the left. So these are two panels that are connected through the server to let me do, if I have like a split screen or a double screen, I can actually put one on one screen and the other on the other. So I can also, let's see, so we can go back and then we can go and actually take our data set that we created and start a training run. So this will kick off a training run on the server on a GPU that will allow it to train on the new data. And so I had Claude create this for me, which was just a little like view that lets me see the training runs, how they did. I can view the results, which allows me to not only see like the precision and recall, which aren't great because this is like just a few data points. I haven't put the full data set in yet. But then not only that, I can actually see like what it did. I can see like whether it picked up certain piles or not. Like here you can see the ground truth includes this, which is actually not a great ground truth. I probably need to fix that. But that's an image that's not in the training data set right now. And when I get to that one, I'll fix it so that it only points at the actual garbage here. And then, so then I can see this. I can see how this model performs. What is it discovering? So it actually found this pile over here that I didn't even have labeled in this set, in this this data point that's outside of the training set. It found this one. It found this extra piece of garbage on the road here that the training data didn't have, or the label data didn't have. So it's doing okay, but I've also got more images here, and I can adjust the confidence threshold that it's using to determine whether that's garbage. You can see it found the garbage in the back of this truck. It did not find this one here. But then I can shuffle this, and I can do it on a whole nother set of data. So it's looking through all the unlabeled data. The data outside of the training data set, the stuff that is pending that I haven't approved yet. And it's using that to run inference and see what it can find. So you can see this model's not as good as my original one, but it's a start. And I have this platform now that lets me go through and iterate on this. So let's say that I'm not happy with that, with the training here, and so I want to start a new one, and I've just labeled a few more images. So now I can go here, click start training. I can pick my YOLO model, so I'm going to use YOLO for now, and I can explain some of the reasons for that. One is actually, I'll just go into that. One is YOLO is, I believe it's now a transformer based architecture, so it's better than the old convolutional neural networks I was using. But also YOLO V8 will run very efficiently on a Jetson, like a Jetson Nano Orin, like something like this. Which now what I plan to do is take this, plug it in inside my car, and then after I fly, I will take an SD card, plug it into here, and then have this do the processing on device, making the predictions, and then automatically posting just the predictions up to the web, and then I can save all the data offline on a disk. This is going to save money, but it's also going to save time. And it's going to save time because I don't have to wait to upload the images. I can start processing them on device at the edge immediately without having to wait to upload 1,000 images. So it's going to save some time. But so I'm using these YOLO V8s because I can run them on here, but I can also run the YOLO V8 on the drone. The drone that I bought is a DJI Mavic or Matrice 4T and a 4E, and those drones will take a thing called a manifold that clips in on the top and can run a YOLO V8 model on the drone and then immediately send back the detections to the remote so you can see them live, which is really cool. And then I'll hook that up to DJI's MQTT. It'll automatically go into a pipeline, which then will go to like a Lambda or something that reports them instantaneously. Or maybe I'll just run it on this device after the flight. Or I could even have this thing listening to MQTT, grabbing the images and then doing some processing, or a laptop that does that, and then giving me the ability to view and then spot check things and decide how I want to report it. So here I can set the batch size, I can set the size of the images, the epic size, and then I can select which GPU I want to run it on. So once I do that, I'm actually going to increase this to 300 epics because I did 100, and I'm going to go ahead and kick off training. So now that actually kicks off training, and I have the ability to actually jump in and monitor the logs. And as the epics come in, it's going to actually start presenting the results here of the epics as we go. This was all created by Claude Code under my guidance and requests, and I find it simply amazing. It works awesome. I've already trained a couple models, and we're talking I've spent 3 days working on this now, this new version, from my old version to this, and this is so good. I'm just really excited about it. You can do things like moving this to the raw so you can see the actual raw stuff, and then go back to the formatted view. You can refresh, you can download your logs, go back to training. It gives you a nice little summary up here of like what's going on. You can actually look at old training runs that didn't fail, and see like what they look like from a high level. Jump in and look at their results. It's so cool. So anyways, I just wanted to show this to you because I'm just super excited about what we're getting into with AI. This is something where, like, okay, if you weren't a software engineer or someone who's done machine learning or who's used AI to do object detection from a drone to report garbage, you might not even think to do all this stuff. But because I've done all this stuff, and because I know what I want or what I need to be able to build what I want to build, and because Claude is so freaking amazing, I can just basically point it at things and sit there and work with it and build stuff like this in no time. So I have a lot more planned for this. I'm going to go a lot further than illegal dumping here and start reporting or detecting more things. I got a thermal drone this time, so I want to look at thermal data. I want to look for things like gas pockets under the ground. I want to look for water, pooling water. I want to look for like heat signature issues, things that could be a problem. I also want to look for like cracks in the sidewalk, cracks in the concrete, cracks in the pavement, potholes. I want to look at tree health. Eventually I want to get a multispectral drone and look at tree health. And the idea here is I want to just collect a lot of data about infrastructure in a city so that I can help, so that I know exactly, well, so that we know exactly what's going on a daily basis, and we know how to deal with these things. So there's so much we can do once we have the data, once we understand what's going on. We have the will to make things better, and data is what helps us understand where to spend our time and energy. So yeah, just super excited about this. Let's see. Okay, so this is how I work with Claude Code. So you can see here I have my GPU stats open. It's running a training run right now on the RTX 6000 Pro here on my workstation. Up here, I'm chatting with Claude about one thing, down here another, but typically I'll even have like multiple Claudes open, and I'm just working on, I'll have Claude, I'll have my site like on another screen here, watching it, seeing what I want, and then on this first screen, I'm going through and asking for the kinds of things I want to happen. Now, I don't know if you noticed, but when I was looking at the results here, there was something kind of annoying me, which was that when I went into this, I just created this ability to go in and like inspect this, but look, when I zoom, it doesn't zoom to where my mouse is. It zooms to the center of the screen, and it always zooms back to the main center. It never goes to where my mouse is. So I want to go back and tell Claude to correct that. So I'm going to say, when I zoom on the training results image full screen what do we call that, full screen detections view, the zoom always zooms in and out of the center of the image, and I want it to zoom to and from the mouse location. Okay, so I'm going to tell it that that's what I want. Now Claude's going to get to work. It's actually going to work on this in the background. If I decide now that I want to go and there's something else I want to work on. So I've got these like training plots. These are pretty cool. I'm going to go around and look at stuff. And if I see something I don't like, then, or that I want to change, then I'm going to ask it to. Okay. Let's see. I don't like how these errors don't correlate with the actual failed run. So that's the thing I kind of want to do. So on the training runs page, the errors at the bottom don't correlate, don't associate with their run. I would like the error to appear nested under the run, like the results are. Okay, so I have it working on that. Now this other one it's already fixed the zoom, so let's go back and check that. So now we're going to go look at the results over here. We're going to pull up this one, and hopefully when we zoom, it actually zooms to where my mouse is, which it looks like it's doing. So let's fix it. Okay, this is another thing I think I'd like. So notice that this one is wrong, and I'm seeing it here. But how do I actually find this image to fix it? It's going to be really annoying to me that I saw that this one has bad training data, which I haven't accepted yet, but that's fine. It'd be cool if I could just go ahead and nip that in the bud, because I don't like things to like essentially sit there and like, I know that it's bad, it'll wear on me. So I'm going to open up, I've got another one here, and I'm going to say, I noticed, okay, so I would like in the results detection screen view to be able to jump to the detection, or to the data point in the annotation view to correct any background truth labels I find. So I told it that. Now I told it that I want to be able to jump back to that and label that. So now it also says it's fixed the results back here. So I'm going to go back. I'm going to now be able to look at this error, and the error shows up nicely under the run that errored. How awesome was that? That really, so in the span of like, what was that, 4 minutes, I was able to fix 3 different things that I wanted to fix, like 3 different feature changes. That's pretty nuts. Now we can't work like this on a production system. The thing with AI is that you can move so fast that you outpace your customers. Your customers, like, you can't work like this on a system unless you get customer approvals. And so the thing that I think that's really prescient here with AI is that it's got to be fully vertical. The company that does AI, the more fully vertical you can be, the better. Because you can move so fast if you can just make decisions and make improvements without waiting for someone else or waiting for other processes to catch up. And so I think architecturally what you want to do is you want to create a separation between your AI systems and your result system. So I'm already thinking about, how do I architect this in a way where the results can stay stable? they can look the same, appear the same, while my tooling and my internal systems for working with this data can rapidly evolve. And so if the result of all this is that I have some maps and some images and detections and some descriptions of all these garbage piles that we detect, then maybe I can have an interface that's completely independent of all this stuff I'm doing, that is stable. Everything goes into that. It can even be like a static website that is updated asynchronously through a system like this, posted up into an S3 bucket with a cloud front distribution, and it's there. It's super fast. The data doesn't have to change because it's data from the past. And if I do have to change it, I just overwrite it. So it's like a cached, hyper fast view that I can publish out to customers or people who are using this data. Then I can create mobile views. I can create views for the desktop. I could even push these out to edge devices. And this is like a very interesting idea to me because it separates out the different views so that I can iterate on these internal views where I'm working. And then as customers have requests for the external views, those are like driven by customer requests. So if they want to change on an external view, I can use AI to change that really quickly and make it do what they want. I can work with them. We could even sit down together and actually iterate through these user interface designs for them. So for instance, if they want a map that shows like how to efficiently get from location to location, and they want to be able to adjust that map and adjust the path, maybe add some extra stops in there, and then they want to be able to click a submit button, and that sends it off to an API, which then adds it to all their work crews routes so that they can kind of plan the day. Those things are all possible, and it's like totally separate. But the cool thing is I can iterate on that completely independently, and I can do these things so fast. It's just insane. So you can see here, my training run is still running. It says it's 36% through. That Claude added to the button for the training view. It added a real-time update of the progress. And so I can go in here, it shows me the progress. I can jump into the logs. I can watch what's going on. It's telling me that it's on Epic 112. It's using 29 gigabytes of GPU memory. I can probably up the batch size. And it's kind of getting, it's still not great. It's got a long ways to go to get good, but keep in mind this is a object detection where it's a tricky problem to solve. Everything is a little bit different, but it'll get there. What would be really cool though is while it's training, if I could have it run inference periodically and do like validation. So let's say we also would like to have it go and do like a validation set. So I'm going to go ahead and compact some of this. I'm going to compact all these. And this is like something you don't have to do, but I have read that if you can limit the context size on these models, they perform much, much better. And so when I'm switching topics, I'll typically compact the view I want to use before I start a new topic. In this case, I'm compacting all 3 of my Claude sessions, and that's because I know that I'm done with those sessions for now, so I want those agents free, and it takes a few minutes to compact. In the meantime, okay, this one has done. Okay, so that was a short session, so it compacted everything. I'm going to ask it, during training, I would like to see validation inferences and statistics and metrics periodically. Some configurable number of epochs periodically. Okay, so I'm just telling it I want to, every 5 epochs or every 6 or 10 epochs, I want to see validation results against labeled data that's not in my training set, so it needs to create a validation set. And then I want to see actual inferences on maybe a test set. So I'll need a validation and a test set. Validation is used for metrics. metrics, and test set is used for inference with visualization. Okay, so you see I had a little typo there. I don't worry about that too much with Claude, but I do try to remove as many typos as possible, because based on my understanding of LLMs, I wanted to go to a latent space where there are no spelling mistakes, because that is likely more clean, persnickety code that is quality, because it has fewer typos and fewer mistakes. So I haven't seen terrible results from having typos, but I try to avoid them as much as possible. This one I'm going to let go. All right, so now it's going about making those modifications. Now what I'll do is every once in a while, I'm going to close this, and I'm going to open up NeoVim, and you're going to see that I should have some changes in here. Let's see what we got. Somehow I've overwhelmed my Git here. I don't know. I'm just going to do GSS, git add backend, frontend, because I've made a bunch of changes. SS, git commit. Better logging, errors, and annotation, validation, results, connections. Okay. So I've just basically saved it. It's important to do that really often when you're coding with these agents, because if they go off the rails, the nicest thing that you can have in your pocket is a prior commit that you can just revert to and kind of start fresh. The more these get better and better, the less I have to do that kind of stuff. But it's a little bit of a force of habit. I don't want to lose good progress. So if something's working, I'm using Git like I normally would as an engineer with these things. So let's see where we're at. So we can go in and check our training run. It says we have no logs. Oh, it's rebooting everything, because so while it's doing this, it's actually going in and working with the services. So it's probably restarting my Docker containers and stuff, which is fine. It's fine because I'm developing this at the moment. So while it's doing all that, I'm going to go through and label some more data. I like to just kind of stay on top of these things. So when I'm waiting for it to do stuff, I'll go in here and check things. I'm going to look for any garbage piles I miss or any bad labels. That's a rock, I think. Could be a piece of paper. It probably is. It's a little scrap of paper. I'm going to add that. We're going to add this into the data set. We'll go to the next one. It's good enough. This is pretty clean, but look, there's a box there, but that's not garbage. And that's not garbage. And I think this looks pretty clean. So I'm going to add that as an example of a photo with no garbage. Okay, and is that garbage in the back of that? I think that's a little bit of garbage. I'm going to consider that a piece of garbage. I'm going to label it. Now, I'm labeling these in a way that at training time is okay. At runtime, I mask a lot of this stuff out. These are old photos from several years ago. But when I mask them out, that will eliminate. I'm going to mask out vehicles. I'm masking out anything but the street and the sidewalk, and that will make it so that I don't get reports or I don't get garbage piles that are unreportable, like if they're in the back of a truck. The DPW will not go there and pick them up, obviously, so I don't even want to look at those. And so, but for now, because it sees them, I want to label them so that the model doesn't get confused and think, oh, well, why is that not trash? Some school of thought, and I've heard this, is that you want the model to actually reason about all that stuff. I think that that does actually work pretty well in my experience now. I'm not there yet with the trash detection model, so I am still kind of sticking to my guns, or sticking to my approach of labeling anything that's visible that is garbage. There's some, like for instance, here's some garbage I have here. All right, so that's not garbage. That's somebody's cleaning equipment. Okay, this is a really clean street, actually. So we're going to add that in. Did we remember to add the last one in? Nope, we didn't. And the one before that? Yeah, okay. Okay, this one has a lot of garbage. Look at all that garbage. And there's something I missed. There's 2 things I missed there. So that looks like a shoe. I don't think I'm going to label that. It's just a shoe. This is pretty good. I mean, there's a lot of stuff here. It's getting most of the big stuff. Those are pylons. There's like some garbage here that's in between those that I probably want to label. Once again, large pile is not the right label, but the label's irrelevant. There's only one class in this garbage detection model, and that is it garbage or is it not? Okay, so we're going to add that one in. So now you're going to see there's like so much garbage in this one. And this is like one of the worst dumping sites in the Bayview. All right. So the rule here is we just want to try to not have extra things in these images that aren't garbage as much as possible. So sometimes I'll break up the bounding boxes to be smaller and to avoid including things like car corners. But in this case, I might just leave it as is. But just to show you what I might do there, I might actually pull this down like that. You see that's results in a little bit better. And then actually if I were to pull this up, I get a little bit better bounding box. This is one of the limitations of using bounding boxes versus like masking. But that's slightly better. So, and the model will learn that things in all 3 of these, and then natively the way these models work is that they then, if they see that they're all close together, they will join them together. So it doesn't really matter if you label them independently at all. These are cups and they're garbage. And although I don't want DPW to pick them up, I can handle that through some basic heuristics. Like it has to be a certain size of garbage for me to report it to DPW. Okay, let's go back and look at what's going on with Claude Code now. All right, so when you want to start a new training job, you're going to set the validation metric. So let's go check on some of the things it did, because I don't think we did check them. So let's go back to the training runs. We will. Do we need to? Did I nuke the training runs? Let's see. I'm gonna restart the. Let's see. NV top. Okay, we are running a training run in the background right now, but I don't think restarting will actually kill it. So, and it doesn't matter if it does because we're just messing around here. So I'm gonna do a Docker compose restart. Restart all that. I'm restarting the services. This runs in Docker with a bunch of Docker services for like things like Postgres and everything else. And then I can go back over here. What happened to all my? We can check if there's an error here. Reload the page. Yeah, so we got 500 error. So we're gonna go and tell the Claude that we're getting some 500 errors. Okay, we're getting some 500 errors on the API. I pasted the image. You can just paste images into Claude Code. So I use Claude Code really simply. I'm not running a bunch of like this fancy stuff in the background. I will eventually learn how to do that. I'll add I'm not running extra agents or configuring extra ones. I do use compact and clear. I'm not messing around with my context. Not using any hooks or any MCP. Yeah, this mobile thing could be cool where you just like, what does that do? Claude mobile app, okay. Oh, okay. I'm not using SQL. Oh yeah. Okay, continue. I actually interrupted it. Okay, so it's I don't know why it's not finding the SQL Alchemy module. That definitely was there before. We'll see. It's weird because like the rest of this is working fine, and this is all in the database. But don't worry about it. Just let it handle it. If it can't, then I'll have to jump in. It's very rare that it can't figure these things out. Let's see. So we have any more garbage to label here? And just find a way to be productive while things are working. You know, multitask. That's not garbage, but it's so similar to the texture of garbage. That's probably going to confuse my model a little bit, but that's okay. You know why? Because sometimes it's good to confuse your models a little bit. Sometimes it's good to give them a little bit of like noise. That can sometimes get them out of local minima and maxima. I think I'm going to consider this actually a garbage pile. I'm going to try to label it without those wires in the way, and I'm actually going to expand this one out a little bit. Okay, yeah. So if you don't do AI machine learning, what I'm doing right now is labeling training data, and this is for making an improved version of my model. I want my model to get better, and so I take all the things that my drone sees, that my AI sees, and I try to go in and correct it after the fact. After it's done its job, I'll go back and I'll use that same data, those same images, to help teach it to be better. It's kind of like on-the-job training for the AI. And as it gets better and better and better, I have fewer problems like that. Okay, so let's go look at the training runs again, and let's see what's going on here. All tables are now in place. Let's restart again. Nope. It's not right. Oh, I can actually paste this error. Okay. Oh, look at that. What does that say? Don't panic. Your friendly traceback interpreter. Wow. Thank you, Claude Code, for fixing this bug that you introduced, but which I know you will fix. Don't panic, and you'll be fine. You'll be just fine. Very soon, see, I told you so. I told you so. Okay, so we're going to go back. Now, what I wanted to look at here were the results, because I want to see if I can click from an inference in my results to go and edit the annotations. And I can, which is great. And so one of these, I remember, if I recall, had some bad training data. And I'm going to go check that. All right. Let's see. Okay, it may be one of the ones after I did a shuffle. Okay, that's fine. Those are predictions, not training data. All right, so let's go see if we can find some bad. Oh, that was detecting wrong. That's fine, though. It'll get better once I give it better training data. Okay. This one. Those seem okay. We can check the data there and see if we can make it better, but those seem fine. And that seems good. That's good. That's good. Okay, those are fine. Let's try shuffling again, see if we can find a really bad annotation like we did before. Okay. Whoa, what was that? Is that actually garbage? Yeah, that is. Okay. I have a feeling this one's going to include the signpost, and I don't want to do that. This is something I've realized I want to fix. So now I can go in here. The thing that I just asked it to do, it fixed. And I'm going to make this a more targeted bounding box to say, like, and you can see I missed a lot of stuff in this annotation, actually. So then I'm going to draw a new one right here. I'll fix that one in a sec, and a new one here. Okay, and then another one here. Okay, then I'm going to do this. I'm going to make that smaller. And then I'm also going to make an annotation here, an annotation here, and an annotation here. Now that I know that there's a couple bad ones, I probably realized I didn't do a great job on this one in the first place. So I'm going to do a quick scan for any garbage. Do I see any? No. And I can now save these changes, add that one back, and we're good to go. Actually, that one was never in the training data set, but that's just fine. That's just fine. So now we can look at a few more of these. Do we see any green that's not correct? These look right. Okay. Oh, that looks like bad data. I love it when I catch those, because those have been the bane of my existence. These things, I've told somebody about this before, but these rooftop things, if they get in the data set, they cause problems because they look a little bit like garbage bags, metal garbage bags. Well, here's some garbage over here that I would like to label, because this is, although it's not big enough to report, it's big enough for my model to notice. I look at it and I notice it's garbage, and that's my litmus test. If I think it looks like garbage, then I will label it, because I kind of try to think of this as like how my vision works. I try to think about how the AI sees things in relationship to how I see things. And when I see garbage, it pops out at me really quickly. And so it's a really great way to train the model. See, it feels like there's like a cardboard box there. I feel like I want to see if I expand this out. Sometimes that helps me see it because it has a little bit of coloring in it. Let's see. No, that's just that. It's just like an Amazon box or something. Okay, now let's go over here. You see that there's like another shipping, like a little, some kind of packaging. Those are good to label. That's cardboard box, I think, or is it? That looks more like intentionally put there as like a shipping box of some sort. That's not really garbage. There is some stuff in this garden, but I don't think that's garbage. Okay, and that looks like garbage for sure. That looks like just a bag. And we're gonna just, this isn't a great image. It has a lot of confusing data, but there's noise, and that's okay. That's okay. Okay, this looks like it's probably pretty decent. And I think we're good here. All right, so if we go back here, the API is working like it said. We've done all these changes. I'm going to commit my changes, and we're going to call it an end of this video. I should really have Claude write better commit messages, but that's okay. All right, so as you can see, that's how I use Claude Code right now to work on projects. These are side projects that I can iterate on really quickly, and I don't have to concern myself with breaking anything for anyone. I can move really fast. I'm just doing all this locally, and it works awesome. And so I'll see you next time.